Today topic is solid principles. What is solid principle? Solid is a set of 5 important design principles in object oriented programming language that helps developers to write clean code and maintainable and scalable code too. Nowadays, solid principles are widely used in software development. So most of the developers we have to follow to reduce the complexity and improves the code quality, and the final result it reduce the bugs in the application. What are the 5 design principles? The first one is single responsibility principle, means one class, one job, one class, one task. O for open closed principle, open for extension and closed for modification. L for Liskov substitution principle, child should behave like parent. I stands for interface segregation principle, use small specific interfaces. Finally, the D stands for dependency inversion principle, which means which depends on abstraction, not concrete classes. Let's talk about first design principle, single responsibility principle. In this principle, a class should have single responsibility. So one class is handling creation of the user, DB operation, email services. So that's a bad thing, right? Because as per the rule, a class should have single responsibility. But if you see this example, this class is handling multiple operations. So how do you solve this issue? We have to create separate class for each of the operation. That means one class is handling one job. It's straightforward. Just remember that a class should have single responsibility. Now I'll start with one example. Spring IO. Let me create a new project. So com.techvika. So TechVika projects. It's in jar. I'll go with the 25. I'll try to choose web. Data JPA. Okay. I've created the project. Just copy idea projects. Keep it here. Zip. Extract here. Okay, our project is TechVika project. Let me import into IntelliJ. Desktop, idea projects, TechVika projects. Okay, load the Maven. Let me quickly open projects. Which version I'm using? 25. Let me quickly verify that as well. Okay, that's cool. 25. So let me start with the user controller. So what I did, I have created the entire class, which this class is contains. I have created one task. If you see this inside this task, create user, saved into DB, send email. So basically this class is handling 3 tasks: business logic, DB logic, email service. So this class is violating the single responsibility principles, right? So how to solve it? Simple. Separate class for each. So just create one more controller. Let's say controller v2. First copy everything. Now I don't want these 2 services from here. Now see, in this class is handling only user created. Now I'll go to the another layer. Same thing. Copy. Go here. Instead of the controller, just give it to repository. Now what I need of, go here, just copy it, same thing. Okay, just remove this business logic and email services. I don't want all these things. So what I want, save DB. Now see this. This class is containing only saving the DB operation. Let's move into another package called service. Similarly, just copy user control, the service layer, go here, instead of controller, just give the user email service. Just copy it, the previous one, copy, go to here, instead of save, send email. Okay, so what is that logic? Copy this email logic. Now let's see that all classes looks good. Let me explain again. This is the first class which I have created, which contains three different operations: business logic, DB operations, and email service. So which is breaking the single responsibility principle. Instead of that, as per the rule, separate the class for each. That means each class is handling different operations. That's the reason I have created one controller for only creating the user, and I have created DB class for only saving the database, and I have created one email service which is only sending the email. That's it. The second principle is open closed principle, which means it's open for extension and closed for modification. The meaning itself, don't change existing code, just extend it. You should add new features without changing existing code. The problem is, let's say there is a notification service, email and SMS notification. We are trying to add other push notification or WhatsApp notification. You must change existing code, right? This one I'm talking about. Okay, in this class there is an email and SMS. Now in the future, if you want to add something called push notification or WhatsApp notification, you have to break this rule: open for extension and closed for modification. So instead, what we can do, instead of modifying this class, we can simply create one interface. Let's say notification service. Okay, inside my interface, what I will do, let's say void send something, send the notification. Now I want, one second, let me close all the email and SMS. Instead of keeping everything in one area, I'll just decouple it. So Java class email service which implements notification service, just override it. So this class is talk about email notification. Similarly, SMS notification, create a class SMS notification which is also implements notification service, just override it. Okay, so this class talk about SMS notification. Now this is the common service which we are talking now. This is an old one which is breaking the open closed principle, because we have to change this class if there is any future notification. So instead of that, I'll just change one time as a generic code. Just inject notification service. I'll go for field level injection. I don't want all these such type of things. I'll directly use notification service dot send message the type, let's say. Now you just remove it everything. You don't want it. Now see, this is generic class now. Now if you want to add, let's say something called WhatsApp. Similarly, copy this one of SMS notification, paste it, just rename to WhatsApp notification. Just instead of SMS, WhatsApp notification. This is how we can make it, which is clearly states that open for extension and closed for modification. You should add new features in the new class without changing the existing code or old code. Next principle is Liskov's substitution principle. The child class should replace parent class without breaking the code. In general, subclass should behave like parent class. Wherever we used parent class, it should not break anything. As a best example, if bird can fly, don't make penguin extend it because penguin can walk. Let me show you some real example. I'll create, let's say, first go with the add design. Let's say bird. We have the class called bird. Inside my bird class, there is a method called void fly method. Flying. Now what I will do, I will create penguin class. What I will do, this penguin extends to bird class. Now what I will do, since I already extended, just override this penguin fly method. Do you think penguin will fly? No, it will walk. Right, so that is the reason. Just to throw new, which one? Unsupported. Unsupported may be operation exception. Let's say can't fly. Right. Now this is a very bad design. If you see that bird can fly, which doesn't means all birds can fly, right? So penguin is a bird, but it cannot fly. It will walk. So it's a very bad design. So how to make it? Let's say if I'm trying to, there is a main method. Now what I will do, I'll just create object for parent. Just check it. So bird is equal to new penguin. Now bird dot fly method. Let me run this quickly. You will understand. We can see that there is a cannot fly. How do you make good design for this? What I will do one thing. First, keep this bird fly method, just cut it here. Just create one interface called anything name called flyable. Inside in this flyable, I'll use the only fly abstract method because this is an interface. It won't allow the normal methods, so I just added abstract method. So now I'll go back to penguin. Now there is no flying. Now you just consider penguin is a bird, so bird is nothing. Now again you can create one more bird, let's say sparrow. In this sparrow, right, sparrow extend to the bird, and this bird, whichever bird implements to the flyable, right? Now you can see this is how the best practice we can create it. If you see the existing one, the penguin, right, the penguin is extending to bird class, but inside the bird class there is a fly method which is clearly violates because it cannot fly. In this penguin cannot fulfill the parent behavior. That is how it is breaking the Liskov's substitution principle. That means subclass should behave like parent class, but in our case the subclass is not behaving like a parent class. So other principle is interface segregation principle. In this principle, don't force a class to implement method it doesn't use it. Instead of split those interfaces into smaller one. Let's see very quick example. Now this is ISP. Let me create package called ISP. So interface segregation principle. It's similar to Liskov substitution principle. I'll take same animal. So inside here there are void animal can eat, and also I'm writing animal can fly. Now what I will do, I'll create one dog. So dog is also animal which implements animal. Okay, just override the abstract methods. It's a bad design, right? See, dog can eat but dog cannot fly. This is how where interface segregation principles comes, right? Here the class, this dog class, forced to implement extra method which doesn't need it, right? If you see about the principles, LSP, it's talk about only interface behavior, not interface design. That is parent, child, child, parent. But ISP, it's talk about the only interface design. We have to split it basically. So this is a bad design. One is talk about inheritance behavior, other one talks about interface design. Now we are talking about interface design because in this interface there are extra methods. It's a bad design. What I will do, similar to eat method, right? Just leave it as it is. In the animal, what I will do, just to create, I'll just split this interface into two more. Okay, one is eatable. Okay, the other one is, again you copy flyable. Just right, take one more interface, select interface, flyable. So inside flyable, fly method. Right now, instead of keeping everything into one interface, I just split it two different interfaces. Now see that the dog implements not animal, only eatable. Just remove this fly method. Now a dog is perfect. Now I want to go with bird class, which implements bird can also eat and bird can also fly. Next principle is dependency inversion principle. In this principle, it depends on abstraction. Abstraction means interfaces, not on concrete classes, which means high-level models should not depend on low-level models. Both should be depends on abstraction. Example, don't tightly couple classes. Use the interfaces. Instead of the classes to auto-wire, you just use the interface to auto-wire. That's the simple. Let's say here there is an email service, there is a method called send method. Now you see it's an user service. I have created object for my email service. It is tightly coupled because I am directly using the class. As per the principle, what it is not depending on the abstraction, right? So user service direct depends on the email service. That means it's tightly coupled. So instead of this class, you just use here notification. That's it. I'll try to write it. We already have notification, right? So now we'll go to the email service. So email service implements the notification service, right? Okay. Again, we'll create SMS also there, right? So SMS also implements the notification service. Now what I will do, I'll go to the user service. Instead of this tightly coupled, I'll use here notification service. Now auto wired, right? So use this email service and then call it. Yeah, that's all. In the summary, single responsibility principle means one class, one job. OCP, open closed principle, add the new features without changing old code. LSP, Liskov substitution principle. Child should behave like parent. It's about the inheritance behavior. ISP, interface segregation. Small interfaces are the better. The class forced to implement extra methods, right? DIP, dependency inversion principle. It depends on the interfaces, not concrete classes. ఇలాంటి టెక్ టిప్స్, ఫ్యాక్ట్స్ అండ్ ట్యుటోరియల్ కోసం టెక్ వీకాను ఫాలో చేసి సబ్స్క్రైబ్ చేయండి. ఈ వీడియో నచ్చితే లైక్ చేసి మీ ఫ్రెండ్స్తో షేర్ చేయండి. థ్యాంక్ యూ.